Hi, my name is Carla Horvath and I will be participating in Challenge 2016, and I will be demonstrating number 5 from the Challenge Calculus Pre-Test. So this problem is taking the integral of a rational function, x cubed, over x squared plus 3x plus 2 dx. So first thing is first. Because the degree of the numerator, which is x cubed, is greater than the degree of the denominator, the x squared, we are supposed to use long division. So to set up the long division, you do the denominator on the outside and the numerator in the inside. However, because it's just x cubed and we want every x value to have a constant, we're going to do x cubed plus 0x squared plus 0x plus 0 just to hold those as placeholders. So now we ask ourselves, how many times does x squared go into x cubed? Well, that's x, so we put the x up there. It's just like regular division. Now we're going to multiply that x by every term in this expression. So x times x squared is x cubed. X times 3x is 3x squared, and x times 2 is 2x. Now we subtract it and get a difference of negative 3x squared minus 2x. Now we're going to do the same thing, where how many times does x squared go into negative 3x squared? Well, that's negative 3 times, and as you can see, we put it over the constant. So negative 3 times x squared is negative 3x squared. 3x plus negative 3. 3x plus negative 3 is negative 9, and 2 times negative 3 is negative 6. Now if we do that difference, we get these cancel out, and negative 2x plus 9x is 7x plus 6. So this is our remainder. Now, after the long division, you can say that this initial rational function that we had at the beginning is the same thing as saying x minus 3, which was our solution from the long division, plus the remainder, right there, over the initial denominator. So now we're going to carry on with taking the integral. So we're going to take the integral of x minus 3 dx and the integral of 7x plus 6 over x squared plus 3x plus 2. So we just broke these two phrases up. But we'll be focusing on this one initially. So where we left off is we're going to be focusing on this integral first. So we're basically going to split this into two. We're going to take the 7x plus 6 off the numerator and put it by itself, and then do times 1 over the denominator factored out. Now we're going to do a thing called, so this next step is a way of rewriting this expression right here, and it's called partial fraction decomposition. So to do this, we're going to split this part up. So we're going to do a over the x plus 1 and b over the x plus 2. Now we multiply each by the opposite denominator. So a is going to be times x plus 2 and b is going to be times x plus 1. The bottoms cancel out, and you're left with 7x plus 6 from here equals a times x plus 2 plus b times x plus 1. And as you can see, they went with the opposite denominator. Now if we multiply these out, we get 7x plus 6 equals ax plus 2a plus bx plus b. Our next step is to take the x out and factor it. So 7x plus 6 equals x times a plus b, because both of those have the x term, plus the remaining 2a and b. So now if you look at this equation, you can see some similarities. Something times x plus another number. So the a plus b has to be equal to the 7 because it's times an x, and the 2a plus b has to be the same as the 6. So if you make two equations, a plus b equals 7 and 2a plus b equals 6. You can use this to form a system of equations and solve for b and a. So I put the 2a plus b here equals 6 here first, solved for b, got 8, then plugged it back into this equation and got a equals -1. So now you're left with the equation 7x plus 6 x plus times x over x plus 1 times x plus 2, which is our initial thing, equals 8 over x plus 2, which is the b over x plus 2, minus the 1, or a, over x plus 1. So basically here we just plugged in our a and b into our initial expression we had there. So now that we have these new expressions from our partial fraction decomp, we can add in the original part, so the original other part, because we were just focusing on this for the partial fraction decomp, but now we're going to add this back in. So that's there, and then this is the partial fraction decomp, just split up so that each part has its own integral. So if you take the integrals, you add a degree and put it over that same number. So x would be x squared over 2, and this you would add an x, so minus 3x. And here I just pulled out this constant plus 8, and then the integral of 1 over x plus 2 minus the 1 over x plus 1 dx. So now you can do u substitution. Say for both of these, actually the same thing, I just demonstrated it with this one. U equals x plus 2, and therefore du equals dx. So the integral of 1 over u du is the same thing as ln of u. And then you substitute back the x plus 2 for u, and you get ln of x plus 2. And the same thing would happen here, just ln of x plus 1. So there, you're left with your final solution. X squared over 2 minus 3x plus 8 ln x plus times x plus 2 minus ln of x plus 1 plus a constant. We did the constant because it's indefinite integral. And yeah, thanks for watching.